We're just solving problems using trig. So just in general, sine law, cosine law, there may be a little bit of Sohcahtoa thrown in there. Okay, so just solving problems in general with trig. So to solve a triangle, there's different approaches. Okay, to actually solve, that means find all three sides, all three angles. Okay, so what you're going to do is you're going to use one, two, or all of the theorems below. Okay, so approach, if we're looking at the Sohcahtoa and Pythagorean theorem approach, it can only be used when solving for right triangles. Okay, to solve for an angle, we need two sides, or to solve for a side length, we need one angle and one side. Okay, so the question gives us either of these two situations, we can keep solving for that triangle. Now, sine law. Sine law is used for non-right triangles, so predominantly in this course, acute triangles. We need a matchup plus another side or a matchup plus another angle in order to solve. Okay, so if we're given that extra side, we can solve for the angle. And if we're given an extra angle, we can solve for a side. Okay, now cosine law. Again, this is for non-right triangles. Okay, so we can solve for an angle if we're given three side lengths, or we can solve for a sine length if we're given two sides and specifically the contained angle. Okay, this is just a summary of what we've done over the last couple weeks. Example 1, a boat in a race starts at point A. So let's draw point A and sails 18.3 kilometers to a red buoy. So let's call this R and let's label this 18.3. Okay, and then it sails 29 kilometers to a blue buoy. So let's call that B and we'll call that 29 as in kilometers. Okay, and let's just close our triangle. All right, so read this carefully. The angle formed by the line of sight from the red buoy to the starting point, so this is where the person's looking, from the red buoy to the starting point, and then the red buoy to the blue buoy is 62 degrees. So we're trying to solve for, how far is it from the blue buoy to the starting point? So we're trying to solve for R. So when I look at this, I know that we have two side lengths and a contained angle. So I'm going to use cosine law with R, and we can actually directly solve for R. Okay, so we have R squared equals A squared plus B squared minus 2AB cos R. Okay, so R squared equals, we're going to get 29 squared plus 18.3 squared minus 2, 29, 18.3 cos R. Nope, it's not cos R, it's cos 62. We know that angle. We're solving for little r this time. Okay, so 29 squared plus 18.3 squared minus 2 times 29 times 18.3 cos 62. So we get 677.59, and when we root both sides, we get 26 kilometers. Okay, so we can write a therefore statement. I like to box these. Doesn't feel complete without a box. So let's go, therefore, it is 26 kilometers from the blue buoy, U-O-I, to the starting point. There we go. There's our therefore statement. Mountain climbers are at the top of the mountain, and there are two rest stations at the bottom of the mountain, one at point A which is due east. So as soon as I hear this, I go never eat shredded wheat. Okay, east of the mountain with an angle of depression of 29 degrees. Okay, so the mountain climbers are up here. This is 29 degrees. That means this is also going to be 29 degrees. Okay, the other rest station is B, which is due west of the mountain. The angle of depression is 35 degrees. All right, 35. Here we go. Okay, so the rest stations A and B are 8.2 kilometers apart. Which rest station is closer to the mountain climbers and by how much? So pretty much we're solving for A and B because we want to see how close the mountain climbers are to the rest stations. So what we have here is we have two angles and we have one side. So let's actually find, let's just call this C. Okay, let's find angle C. So angle C is going to be an easy one. It's just 180 minus 35 minus 29. And we get 116. Okay, so this one right here is 116. So now what we have is we have a matchup. We should be able to identify that right away. So because we have a matchup, we can solve for A and B as well. Okay, so we're going to solve for side A. So let's put C over sine C. And that's going to equal A over sine A. And that's going to equal B over sine B. Okay, so the full ratio that we have is 116 over, no, I'm wrong, 8.2 over sine 116. Okay, and then we have to solve for A over sine, and then the angle A is 29. So all we want to do is bring that up. We're going to get 82 sine 29 over sine 116. And that's going to equal A, and we can put that in our calculators in one shot. So we get 82 times sine 29 divided by sine 116, and we get 44.2. And that's going to be kilometers. Okay, now let's solve for B. So again, we're going to use 8.2 over sine 116 because we have that full ratio, 8.2 over sine 116, and we're going to equate that to B over sine 35, which is the angle for B. Okay, cross multiply that up. We get 8.2 sine 35 over sine 116. So we get B is how far away? 8.2 sine 35 divided by sine 116. I get 5.2. You know what? I think I made a calculation error. I put in 82 here. I'm supposed to put 8.2. That looks better. I was going to say they're very, very far away from these. 4.42. Sorry. This is going to be one decimal over. Okay, so we have station B is 5.2. No, station A is 5.2 kilometers away. Station B is 44 or 4.42 kilometers away. So which one is closer? Well, it's easy to see that station A, which is side B, station A is closer. And if we do 5.2 minus 4. Let's go 4.4. 0 decimal is 0.8. 0.8. Okay, and don't let these confuse you because side A is going to be closer. Right. Side A is going to be closer, which is actually station B. So therefore, station B 0.8 kilometers. Okay, example 3. Ryder and Alexis are scuba diving below the surface of the water, and they're at the same depth. Okay, so here's the water, and they're 20 meters away from one another. So let's call them A and R, and they're 20 meters away. Okay, so when looking up at the boat, Ryder can view the boat at an angle of elevation of 34 degrees. Okay, while Alexis views the boat at an angle of elevation of 48 degrees. How far is each scuba diver from the boat? So, very similar question. This is little r, this is little a. Okay, we can find, let's call this B for boat. Okay, let's find angle B. Angle B is going to equal 180 minus 34 minus 48. Okay, the 180 minus, and I get 98 degrees. And then what we can do is we can use that 98 because now we have a matchup. Okay, we have B, angle B, and side B. So we have B over sine B. And we can solve for A over sine A. And we can solve for R over sine R. Okay, so the complete ratio that we have is 20 over sine 98. And let's solve for A over sine 48, and we'll solve for R over sine 34. Okay, so let's solve for A first. So I'm going to write in an expression for A. So it's going to be 20, because we're going to cross multiply, sine 48 over sine 98, and that's going to equal A. So 20 sine 48 divided by sine 98, I get 15. And that's going to be meters. Okay, and then for R, I'm going to cross multiply the sine 34 up, but still using the full ratio that we have. So 20 sine 34 over sine 98, and that's going to equal R. So R is going to equal 20 sine 34, 11.3. So 11.3 meters. There you go. So we can say, let's go in red. Okay, so we can say, therefore, Alexis is, okay, so really actually look these up, because Alexis is the side R away from the boat, so 11.3 meters, and Ryder is 15 meters from the boat.